Today I'll be talking about task 2. In this graph you can see that Bolt accelerated before slowing down. We can see this by looking at his splits. In his first two splits the change in velocity was 8.93 and 2.65 meters per second. Amber Anning also accelerated in her first two splits, then again from her third to fourth. Her first change in velocity was 6.83, her second was 3.35. In her fourth split, she had a velocity change of 1.53 meters per second. In my 200 meters, I accelerated throughout the first three splits. My first acceleration was 6.08, the second was 1.01, and the third was 0.31 meters per second. Throughout a 200 meter race, rectilinear and curvilinear motion are present. Rectilinear motion is when the athlete is running in a straight line. Curvilinear motion is when the runner is running around the bend. The average velocity for Usain Bolt was 10.42 meters per second. Amber Anning's average velocity was 8.26 meters per second. My average velocity was 6.2 meters per second. These numbers don't mean much as we need to analyse the intervals for each athlete. The weight of the athlete plays a big part in a 200 meter race. The heavier they are, the more inertial mass they carry, and the more force they will generate when coming out of the blocks. In the blocks, all athletes have a momentum of 0. The mass of an athlete is calculated by weight times gravitational force. The mass of Usain Bolt is 922.14 newtons. As he has the most mass, he will have the most inertial mass and generate the most force out of the blocks out of all three runners. Amber Anning's mass is 598.41 newtons. She will generate the least force out of the blocks out of all three runners because she has the least inertial mass. My mass is 686.7 newtons. The velocity values at 50 meters are different for each runner. For Bolt, it was 8.93 meters per second. For Amber Anning, it was 6.83 meters per second, and for me, it was 6.08 meters per second. We can see that Bolt had a 2.85 meters per second higher velocity than me. Amber Anning had a 0.75 meters per second more velocity than me. These athletes have not reached peak velocity, they have only just left the blocks. As the athletes have only just left the blocks, it means they won't have much momentum. From these graphs we can see that each athlete has a low momentum in the first 50 meters. This is because they're not up to speed. Usain Bolt has the biggest increase in momentum over 50 meters. Then it was Amber Anning, and then it was me. We can see that over 5 seconds, Bolt had the steepest line. This means he had the fastest acceleration. The second steepest line over 5 seconds is Amber Anning. I had the flattest line over 5 seconds. These lines are good indicators of how well the athletes did in the 200 meter race. During the 50 to 100 meter part of the race, all three athletes accelerated. This is because they have started to gain more power as they have left the blocks. Each athlete has also seen an increase in momentum because of this increased acceleration. We do not see the effects of fatigue this early in the race, with a few changes. The speed of Bolt and Anning decreased due to fatigue. My speed increased as I tried to conserve all my energy and use it equally throughout the race. Both Usain Bolt and Amber Anning had a decrease in acceleration, which is also due to fatigue. My acceleration continued to increase. Due to the fact that Bolt and Anning's speed are decreasing, it also means their momentum is decreasing. However, my momentum is increasing as I'm still getting faster. Both Usain Bolt and I decreased in speed in the last 50 metres. This is because of fatigue. Usain Bolt went from 11.06 metres per second to 10.53 metres per second. This is only a slight decrease. I went from 7.40 metres per second to 4.89 metres per second. This decrease is very significant. We also both decelerated. By adding the increase of speed from 7.66 to 9.19. This shows she conserved her energy and had enough for one final push, which made her run fast over the finish line. She also accelerated.